Hello, I'm Eric Snodgrass, and thank you for watching this Thursday night, May the 4th, in-depth ag forecast brought to you by Nutrien Ag Solutions. I want to go back here to a longer animation of some of the radar data we've seen here recently. And what we're watching is the storms from last night and what they did throughout the day today on Thursday. Plenty of rain fell finally in parts of the Texas Panhandle. This moved across parts of Oklahoma, and we're going to watch this area again tonight. Already the storm's starting to pop right in through here. You can see that convection opening up too as this kind of deeper low sits over the west. It's brought a bunch of rain into California. It's been spreading storms, as you'll see right here at the very end of the animation, through parts of the Intermountain West. Finally, we have gotten rid of that deep trough that has been sitting here over the eastern part of the United States, and I'm glad to see that one go. Because when we just look back over the last 3 days of total accumulated precipitation, this has brought in snow, this has brought in graupel, this has brought in incredibly cold rain, and it's still going to leave us with a lingering cold morning tomorrow right in through this part of the country, right in through here. But to see some of the moisture returning down here into the southern plains and what we're expecting to see over the next 10 days or so is going to be very refreshing for what we've been watching this spring. But I still have some big ideas that I'm conflicted a bit about, and I'm going to be honest with you. Some of the things we're going to talk about in this video, I've just lately kind of just pulled out some new evidence that I just want to have a discussion with you about it. Okay. First, though, I do want to show you some of the satellite data from this because it's just been impressive to see the convection out of these storms. And so we are going to be watching this corridor this afternoon or this evening for the risk of severe storms as part of Texas and Oklahoma. And also these storms could drop some hail, and they do have quite a bit of moisture in them. But just take a look at this deep low that is sitting here over the west. And let me show you this kind of longer animation here. We can just see this large area out ahead of it just pulling up over the mountains, a lot of just convection on the mountains. So there are storms not only in Texas, but they just roll up the front range of the Rocky Mountains, clear up here into Idaho and Montana. And as we look at it on satellite, we should also take a quick look and see what the latest lightning data looks like. And it's interesting because sometimes we don't see imagery like this, where there's all this scattered lightning throughout the west until we get into until we get into summer. There's one big difference, though, and that is that the storm is curling this way. In summer, we typically see it go that direction around a larger ridge that often sits over the Great Basin in the middle of summer. And that's going to be one of the big things that I'm trying to assess if the storyline that I've been carrying throughout the spring is still valid. So we need to start having that conversation and kind of pressing forward with this. And here's the reason why. You see, the latest model runs, if we look in the near term, this is where we're spreading precipitation throughout the day on Friday, getting into Saturday, and getting most of the way through the day on Saturday. So a couple of things. The precipitation that's coming through this part of the country. Earlier in the week, it was expected to go farther to the north, but now we're missing a bigger section of Missouri. We're missing a bigger section of Illinois. And I have a feeling that a lot of you that are in this area that have been dry look at these forecasts and keep seeing the same thing. There's kind of an overpromise in the forecast models for precipitation that then doesn't materialize. But we do see more precip coming into parts of the western Corn Belt in the upper Midwest. And of course, as that deeper low just continues to spin, it's going to put down quite a bit of moisture into the Pacific Northwest as well. But what I'm talking about here, bigger picture things, is that over the last couple of weeks, and this is really the last 2 weeks here, we can see just a very strong contrast between where this precipitation pattern has really laid down a lot of moisture. So I'm talking about this corridor in through here, eastern Texas, parts of the southeast, and then a big section here up the eastern seaboard from Florida clear to New England. And then, of course, the heavy snow that was around the UP. But what we're also paying attention to is this. This is a large area of very productive land that has been receiving less than adequate precipitation. Now, we don't expect to see heavy precip this time of year down in this part of California, Nevada, Arizona, New Mexico. But we need to start to see if the pattern's going to improve in that area, because I've had kind of a long-standing forecast of saying we could see a weaker monsoon this particular summer. So it's getting the moisture there now that I think could be critical if we could get it to fall. But what was important about seeing this 2 weeks, 3 weeks of dryness in this area is that it's now showing up on the newest drought monitor. So this was released this morning, and we've now seen this area expand a bit, including now more of Iowa, Missouri, and Illinois that have now shown up with the abnormally dry category. And we can compare this to lots of different fields. Like, for example, the surface soil moisture down to about 16 inches. There are just deficits in that area that we're talking about here. Now, these aren't the only dry places. I'm just trying to show you kind of the bigger picture, the more contrasting pattern here of where the moisture has been versus where it has not been. Okay, this is what I want to do. I've made a case so far this year that the rapidity, the speed at which we're seeing this El Nino come on may make it the most dominant feature going forward. And I've mentioned numerous times that there are competing factors with this, like the negative phase of the PDO. We've often talked about, in fact, let me just get over to the ocean temperatures while I'm bringing this up. But we've also talked about the warm water that's in the Gulf and the Caribbean over here. And we've talked about the position and strength of the Bermuda High. We've talked about the MJO being on the move right now, a good indication of an open and active and moving pattern. But as I've been really just stopping and thinking about where we currently sit with this, I just want to make a point that right now, this PDO signal in through here, this, if we're thinking about summer, I think that is going to be the most important factor to watch. And I think the next 30 days will be the most telling on this. So I'm going to make a quick statement about it, but then kind of add some detail to this, okay? The statement is, if these ocean temperatures remain as cool as they are, the PDO does have a better chance, especially through June and July, of still being the most dominant factor. You could make a big argument right now that it is, because we keep seeing West Coast troughs. We keep seeing high pressure build right in through this area. Those are telltale signs of a negative PDO. But should these ocean temperatures fade and the the El Nino continues to build as fast as it has been forecast to do, then we may get a quicker transition to where El Nino becomes the dominant pattern. And I'm just going to tell you what this means. If the negative PDO hangs on, there's going to be a lot of folks in the western United States that are going to see lower vapor pressure demand. They're going to see lower evaporation rates, less extreme heat, and also probably better spring moisture, better storms in the Pacific Northwest as an example. If the negative PDO hangs on, the central United States, large area in through here, has a higher chance of seeing regional drought development and longer stretches of drier weather. Now, if the PDO doesn't, flip that narrative. I mean, that's exactly what tends to happen. So let's just consider what these options are. First, I talked about the speed at which this El Nino is developing. From February all the way till now, we've actually seen the ocean temperatures rise about 1.25 degrees C, almost 1.3 degrees C. And that has been a very, very fast rise in those ocean temperatures. And you know that I have looked through a bunch of analogs. We talked about this on Monday. And you know that I still feel a bit hung up on the 2009 analog. And that's because on May the 4th, 2009, we still had a very strong PDO signal. Now, is it as strong as it is this year? No. This year, it's all the way down to around -3. This wasn't quite to that point. But we did have a developing El Nino right in this area. And by the time we got into July, look what happened. This is the July 2009 ocean temperature pattern. We see that the negative PDO signal faded, El Nino dominated, and this ended up producing a much more favorable growing environment for precipitation and temperature through much of the central United States. I mean, a large section of it. The Corn Belt, the Winter Wheat Belt, down to the Cotton Belt. This was overall a more favorable scenario. So that's what we have to watch for, okay? Now remember, 1 year does not an analog make. So we can't just say, oh, it's going to be like 2009, done. I'm just showing you a year that I'm seeing some similarities to. That's the main story here. So right in this area is what we're going to have to watch most carefully. I will make this comment, all right? The speed at which this El Nino has developed has matched what several of the modeling forecast centers have suggested, especially the European. So to be right now at about 0.3 C here at the beginning of May, that's right inside of this ensemble average. So this is it. This is the big question. If the El Nino dominates, we will likely see more northwest flow in the midsection of the country around a ridge over the west. We tend to get more storms in the central part of the United States, and they propagate themselves to the east. Should it not, then we will tend to produce more of a ridge in the central United States. We'll see ridge-riding storms around its periphery, but it could open up a big section of the central U.S. to drought risk, more exposure to it. And that's it. And this is what I think I'll be battling with the entire month of May as we look at these longer range forecasts. So I'm going to ask you to be patient with me. I'm going to ask you to understand that the signals are not clear, and May is going to be a critical month to tell us what the summer setup is going to be. All right, from here, let's now show you one last thing about this. If you look in June, July, and August at the correlation with that PDO, because I made the case for the El Nino, right? If we look at the PDO signal, what we're looking at here is a relationship with precipitation. Now, when you look at the color bar, these would be positive correlations and this would be negative. But understand this, we have a negative PDO, so these colors, the warmer colors, represent where there's the risk of being drier than normal. But I need you to know that most of the climate reporting districts that this survey or this analysis has been done for, these are correlation coefficients that are, somewhere in like 0.4. And just to make a point, remember, if you look at the correlation, it's always looking between two variables, so like x versus y. This would be a perfect correlation. When you look at this, it's scattered kind of in a larger area like that. That's what a correlation of 0.4 looks like. If you were to go up to 0.9, they would sit almost directly on this line. And if they were inversely correlated, it would completely flip itself around. So what I'm trying to stress here is that there are many factors that control summer weather. Why we're talking so much about El Nino and the PDO is they're the only preseason factors we have at our disposal. Well, that and these soil moisture values. So if you said, what would it take if I'm in the central United States where it is dry, what would it take for me to not worry about drought? The next 30 days are critical. Wipe this out. That's key number one. Second thing, El Nino, keep it developing at the pace that it is. And the third thing, I think you know it, ditch the colder ocean temperatures here off the West Coast. And there's actually a fourth thing with this as well. And it has something to do with the position and strength of the Bermuda High. Now, before we get to the Bermuda High, I just want to point out that we'll get brand new updates from the European model tomorrow. And I'm excited to see that on Friday. And I think I have a feeling about what it's going to show for our precipitation patterns. And I'll illustrate that in just a few seconds. But if you see the ocean temperature patterns doing this between now and July, where the El Nino comes on, the cooler water fades, the warmer water here expands toward the West Coast, this is the setup that keeps much of the plains and the Midwest all the way to the east wetter than average. All right, that would be the setup. And how we would get it is the flow would split over the west, come out of the northwest in summer here, meet Gulf moisture, and then take off to the east. And that would be the scenario that we would get. What could complicate everything? In fact, it's even possible in summer to completely negate the PDO signal or the El Nino signal, is the position and strength of the Bermuda High. So I just fast forwarded this to May 7th, and we see these big high pressure cells. Now, if the Bermuda High in the middle of summer sat right here, this would be a terrible situation for the East Coast and the Southeast, and we would have a lot of rain through the Midwest and through the plains. If the Bermuda High wasn't here, but instead out of Bermuda, we tend to all do better. That tends to be good for the East Coast and the central United States as well. So we'll be talking about that, but that is a sub-seasonal feature, not a seasonal one. Just want to let you know there's one other thing that I'll be watching. Now, the upcoming long-range forecast, the newest stuff that was just released today from the ECMWF, I'm confused by it a little bit. I know what the model is doing, but I don't know why it's doing it. And here's my reasoning. We see right now that the MJO is still moving, right? It's come out of the Indian Ocean. It's moved north of Australia. It's forecast over the next 10 to 15 days to move through the Western Pacific, and I don't have any reason to think it won't just continue. We like that. If the MJO's moving, it tends to keep the rest of the atmosphere moving. We can see it in a couple of different ways. Like look at the velocity potentials. Remember how we talked about the slant between the colors? We still see that in the forecast. And if you want to know if there is an El Nino going on, just take a look at these equatorial winds. All these reds indicate stronger zonal winds, which means we're actually seeing the slowing down of the trade winds and the at times westerly wind bursts. So this is all signal that suggests that El Nino's got a grip still on this pattern. But this was just released today from the European model, like 30 minutes before this came out. And I'm going to be honest with you, I've been down in my basement where I record these with my head just laying on the table thinking through this. Because at this point, the model is trying to park a ridge from May 15 to June 15 in the midsection of the country. And the position of that ridge, if it was there in July and August, would make lots and lots of storms in this area. But right now it's showing up in the model as drier. And there are a lot of you watching this that do not want to see this at all. I'm talking about anybody here in the Midwestern part of the United States. And I will just tell you that I'm going to have to call this into question and spend the weekend thinking about it, because I can make it work in the model. I know why the model is doing this. I can see where it's putting the troughs in the Gulf of Alaska and bumping up this ridge in the midsection of the country. But I don't know why it's doing that, given that things are changing with the MJO. The momentum is decent across the Pacific Ocean. I'm not sure where any longer term blocking is coming from. So I look at it and I just have to question it. I will tell you this, I'm worried that it's also confirming a bias I have. My bias in the forecast was that May was going to be stormy, most of May and going into early June. So to see the model do this, it automatically goes against my thought processes for the last 3 weeks. And you all know this because we all deal with it. It's sometimes hard to, even in the light of new evidence, change the thought process. So I need time. I need to put my head back down on this table and keep thinking through this. So I want you to know that's currently on the top of my list. Now, if I show you the pattern, I'm going to make sure that you understand what we're about to watch as we get out of spring and head towards summer. Okay, so going forward through the remainder of this week into Friday, this is still on. The troughs are in the west, cooling things down, bringing the precip, and we get southwest flow. Now that's been a narrative all week, and we know that this is going to open up with Gulf moisture to produce storms in the central part of the United States and bring in warmth. Now that's through the weekend and then into early next week. And what I'm watching for is anything that can kind of change that. So now you can see when we go out there about May 10th, there's another trough coming to California, hence the cooler, wetter weather there. But I still got southwest flow here. But an interesting shift happens after about May 10th and 11th. And the models are attempting to redevelop, as we talked about on Monday, a deeper trough that's now farther away from the coast. So that allows this one to move. And that could mean that a week from now, we're going to watch for a severe weather outbreak in the central United States. But after this, going out there to about May 13th, 14th, and 15th, I'm getting a sense of some split flow. Now that's going to bring warmth back to the west. And that's going to bring a lot of convergent flow in the midsection of the country in the upper levels of the atmosphere. And what this does is in this area in spring, this is drier. That's a drier mid-May signal in the jet stream pattern. If I was looking at the same forecast, this one right here, and it was late June or July or August or September, I would be talking about the storms that are going to form on this. Entirely different setup in summer versus spring. And so just thinking about that, as I walk through this forecast pattern here, I want you to remember that we're seeing big, wide open Gulf for several days in a row, and then this might be the split flow that starts to mess with the pattern in the middle of the month. Now, I mentioned the open Gulf, and I want to show you an animation from the 12Z European model of precipitable water. Essentially, it's how much water is in the atmosphere to be precipitated out. And we're just going to look up the scale. This would be the wettest conditions, and these would be drier. Now, as I just play this forward, we'll go through Thursday into Friday, then into Saturday and Sunday. You can see it as clear as I can. There is plenty of flow turning this stuff north and bringing it into the plains and into the Midwest. Through Monday into Tuesday, out there into Wednesday. If there is a dry intrusion like this, it doesn't last long. We see right away after that the moisture rebuilding in these areas. And there's just a lot of evidence that we're going to be transporting some good Gulf moisture deep to the west and into the north. Okay, so I'm talking about up toward the Rocky Mountains and then through the Midwest into the upper Midwest. So because of that, there's going to be plenty of moisture to produce thunderstorms. What is different about the pattern is, unlike what we've seen for the last 6 weeks, no deep systems to produce well-defined low-pressure systems, which means there's going to be a lot of scattered storms, and those storms are going to breed other storms. The outflow from them will result in the formation of new storms. So what you're looking at here is the probability over the next 10 days of getting at least an inch of precipitation. And if we step this up to 2 inches, you're going to see that it's going to be quite wet down here in parts of the Mid-South down to eastern Texas. We also see the models aggressively going after moisture in South Dakota, parts of Iowa, Minnesota, and Nebraska. And then some of you are going to go, well, what about in between? And I'm going to tell you that right now in between, this is going to be the area that we know is already dry that's going to be struggling, I think, to get the storms to propagate and move through and over. And it's just model analysis. That's what I'm giving you here as I look at this. So severe weather side of this. This is today. So we're going to be watching tonight on Thursday night here, and then in the mountains around that deeper low. We then go into the day on the 5th, Cinco de Mayo here, right? We're going to watch this part of Texas, also in the lower Mississippi River Valley, but also in Nebraska. We'll see that in a second. And then getting into Saturday, storms. This whole area in through here, in this shade, just has a general risk of thunderstorms with the wide open Gulf transport and these broader features sliding through the United States. So I'd like to show you the models real quick. This is starting off this evening about 7 o'clock. And we're just going to watch the moisture from one system move east, scattered showers in the New England area, and then the showers and storms that are still circulating around the deep upper level low over California. And there it goes. Notice there's some scattered precip in the overnight hours in parts of Nebraska, Iowa, Minnesota, Wisconsin, Michigan. But the heavier rains are in southern Missouri, much of Arkansas, and this slides over into western Tennessee and Kentucky. Now, with that system in the west going into this Friday time period, and into the early weekend, we are going to be seeing snow at high elevation, including the Sierra Nevada, Cascades, and the Intermountain West here. But notice even getting through the day on Saturday, there's still a push here of moisture coming into parts of the upper Midwest and northern plains. Now, as we look at the multi-model analysis where we have the ECMWF versus the GFS, I want to compare the models for you first. Remember, when you see these colors, that's the GFS wetter, and these colors are where the ECMWF is wetter. Do you see how it's just like speckled in through this area? This is what happens when you have lower resolution models attempting to predict convective events like thunderstorms, and they don't tend to do a very good job of it. Furthermore, we've been looking at this week. I want to let you know that the GFS lately has had a little bit lower performance skill scores than the European model has on matching the height pattern. So when we're watching this, we're probably going to favor the animation on the right more than on the left because of those skill scores. So here we are playing through the end of this week, Thursday into Friday. And as we work our way through the day here on Saturday morning, Saturday midday, and Saturday evening, both models have keyed in on storms here, and then the wet conditions, scattered showers and storms throughout much of the Pacific Northwest and here in the Northern Rockies. That would be Saturday night. Playing through into Sunday morning, through Sunday evening here. A lot of just scattered thunderstorm complexes moving throughout the Mid-South, the Midwest, and parts of the plains. This eventually gets over into parts of the Tennessee Valley and over here to the east as well. This is on Monday night. We just keep playing this forward into Tuesday and Wednesday of next week. And again, we see systems coming out in the plains. We see moisture being advected out ahead of them. And there's these chances of bringing in more storms into the central United States. So how do you analyze the models and look at their actual values? Because, I can show you what they're producing. This is what the ECMWF has got for the next 7 days, and this is what the European has. And you're probably going to look at this and find that you're in a hole, and I'm going to tell you something. We're going to get a whole new solution of this tomorrow morning. It won't even look like this tomorrow morning in this area. But I'll just keep coming back to the main point. Over the next 10 days, this whole area, let's get it back there we go, has the risk of seeing a lot of scattered showers and thunderstorms. Okay, from here, we've looked at the models. I want to get out to this, the new update from the Climate Prediction Center. If you saw my video this morning, you'll know that they had the slight risk from the 12th to the 14th for heavy precipitation over a bigger area. They've now reduced that, keeping it more in this Texas to the Mid-South and lower Mississippi River Valley area from the 12th through the 14th. And the models agree with that. This is the week 2 forecast. And you can see that it is wetter, much wetter in this area. Now, why does it look like this? Well, remember, the pattern is split. So we got this interesting split to it. One piece is coming down through here. The other was coming over the top. And right in through this area, we had the net convergence, hence in spring drier. But the models have frequently overpromised week 2 precipitation. We've talked about that a lot. It's quite frustrating to see the models overpredict these week 2 precipitation forecasts. But we'll just watch for it. We'll see if this manifests itself as we get our way out there to the middle of May. Okay, last couple things to do. We better talk about the temperatures. Looking over the next 7 days with the heat opening in the midwestern part of the United States all the way down to the Gulf Coast, we see a lot of accumulation of heat units. As far north as southern Iowa, we're picking up well over 115 GDDs just in the next 7 days. And this is going to be an area that is rapidly finishing up their planting. The cooler areas are going to be in the west. You can see the numbers are quite small, whereas a week ago when the heat was on, these numbers were way high. All right. If we take a look at what the temperatures are doing, let's start off on Friday. A lot of rain, cooled air in this area. Still some cooler conditions exiting in the northeast, but the cooler air is back in with the trough that's over the west. Saturday, getting into Sunday, the warmth really opens in the midsection of the country. And going into next week, Monday into Tuesday and Wednesday, we just see more broad warmth as the pattern just favors less, just deep troughs across much of the central and northern part of North America. So here we go. 15-day forecast of temperature anomalies as a 5-day sliding window. Notice as we get out there day 5 through 10, even the cold signal in the west begins to fade. And as we work our way out there toward and past the middle of the month, the only places that are showing up cooler right now are primarily down here in the south, where we expect a lot of precipitation. This is a lot of cloud cover in this area. I want to show you one last thing with temperatures and then give you a quick update on South America. If we look at the probability, because there's a lot of folks wondering if there's going to be some last hidden frost in this forecast. If we look at the probability of having a low temperature below 40 Fahrenheit, tomorrow morning I'm going to keep an eye right in through here for a frost. But after this, what we're going to notice is the coldest conditions are kept in Canada, or at higher elevation in New England, or at higher elevation in the west. And as we just play this through May 8th into the 9th, 10th, what are we looking for? You want to look for any time these colors just dive down into the central United States. And I just don't see that coming through the 14th, 15th, 16th, 17th. In fact, we'll just take this all the way out there for 15 days. So it appears as though the ridging that's opening up in the midsection of the country is going to be beneficial to kind of steering us away from frost risk. All right, last thing I want to talk about here is South America. We explained this morning's video that we're very dry inside of this area, and you can see it when it's compared to normal over the next 15 days. For most of this region, which has been wet for the last month, this isn't going to be an issue unless we have some late planted safrinha corn, likely farther to the south. But coming out of Paraguay, hitting Rio Grande do Sul, some very heavy rains. In fact, Rio Grande do Sul has seen a lot of drought this year, so this is important. But at this particular stage, as the monsoon begins to slow down, we're probably going to see the maps look more and more like this over the next 15 to 20 days. But right now, the NDVI values on these states in Brazil is at the highest it's been in the last 20 years. So we'll just need to pay attention to see if any late planted safrinha crop is dinged by the drier conditions overall, because it will be hotter in here as well. All right, that's it. I appreciate your attention, and I look forward to keeping this narrative going with all of you over the next several weeks. We'll talk soon. Thanks.